Hi everyone. What I'd like to take you through in this video is basically it's an overview of your study notes. I'm not going to write out all of the definitions and things for you, but what I'm going to tell you is basically from each lesson what you need to know and where it will be covered on the assessment. And so it'll help to frame things for you. And so really the majority of this first video is going to be me taking you through the theory that you need to know and some of the equations that you need to know. So I've broken it up by lesson. So hopefully if you've got some notes from your lessons, you can quickly then fill in on your study notes these definitions so that you've got them in front of you, or at least you can kind of put a little tab on them in your notebook so that as you're doing the quiz or the assignment, you can quickly turn to them to have examples. Okay, so lesson 1 was basically an intro to Unit 4, where we went over some definitions and then we went over the types of solutions. So the big things I would expect you to know here are definitions. And so I'll just write them out here. Here are the definitions that I think you should have available to you so that you could answer them in a theory type question. So the definition of a solution, okay, a solute and a solvent. Okay, so those are the basic ones right off the bat. We talked about specifically when it came to liquids and in liquids, we talked about a miscible solution, which meant that you can dissolve any amount in another amount. Immiscible means you can't dissolve any amount. We talked about the idea of solubility, what it means to be soluble, solubility, and the idea of the term soluble. So those two were kind of interconnected. And insoluble. And these definitions are all in your notes. And then finally, in terms of definitions, we talked about 3 other terms. We talked about saturated, a saturated solution, which means it's got it can't take any more of the solute. Unsaturated, which means more solute can still dissolve. And we also dealt with something called supersaturated, which involves temperature. So take a look at that definition, supersaturated. Okay. The only other major thing from that first lesson, other than those definitions and kind of setting the unit up, was we talked about the different types of solutions. We talked about, you know, solids, solids in solids. We talked about solids in liquids, and that was kind of probably one of the biggest ones. Solids and liquids, etc. So just having a different example of each of the types of the different you know, of the various, you know, solids in whatever, gases and liquids and so on. So I think if you have that as your background, if you have those definitions and examples readily at hand, I think that that's perfect for your study notes. Okay. For lesson number 2. Lesson number 2 was all about, we were trying to answer 3 questions. Okay, so here we go. The 3 questions we were trying to ask were, will something dissolve in something else? How much of it will dissolve? And how fast will it dissolve? And again, I'm not going to fill in your study notes here. I want you to do that because I think the act of filling the study note in is very important. But really, there were 3 things here. There were 3 items that you need to consider. And basically, it was the nature of the substance, it was the ion size and the ion charge. So just know those three things and have those in your study notes. The second thing was how much will dissolve. In other words, if you've decided that it will dissolve, now the question becomes how much will dissolve. So there are two things that you need to consider, the temperature and the pressure. And then for how fast, there are four things I want you to consider. So there are four reasons, you know, are you stirring it? What's the temperature of it? How much of it has already dissolved, things like that. So I need you to kind of have those four things readily available. But again, you can quickly make little jot notes for yourself, and so that you're prepared to answer those questions. Will it dissolve? How much of it will dissolve? And how fast will it dissolve? That was all lesson 2. Okay, lesson 3. And I've put a little note here because I want to talk about one thing from lesson 4, but lesson 3 was mainly about the formulas we use to calculate concentrations. Okay, now there were 4 formulas that we don't use very much, but I'm going to write them. If you were to see these 4, they would be in the multiple choice section of your test. So look at this. We did something called the mass volume percent. And for the mass volume percent, we did the mass of the solute. We did the mass of the solute. And I'm going to put in a note here that it's in grams. And we divided by the volume of solution. And it was in milliliters, and then we did times 100. Okay, so again, this was the first one we did. There's an example of it in your notes, but remember, I want to emphasize here that you use grams and you use milliliters. Okay, the second one we did was a mass percent, and for that one, we did a mass of solute divided by the mass of solution. Okay, this one was in grams. Oops. This one was in grams, and this one was in grams. Okay, so just be aware of that. And then you do times 100 because it's a percent. The third one we did was a volume percent, and here it was the volume of solute divided by the volume of solution. This one was in milliliters. This one was in milliliters. And then times 100. So notice how those 3 look very similar. Mass volume percent, mass volume. And just remember, here we're always using grams or milliliters. Grams, milliliters. Okay, so grams and milliliters. The fourth one that again is not very common was what we call ppm, parts per million, or parts per billion. It's a little bit different, and for parts per million and parts per billion, basically it's going to be the grams of solute divided by the grams of solution, but it's either going to be times if it was parts per million, it would be times 10 to the 6th, and if it was parts per billion, it would be times 10 to the 9th. So just it's a little bit different than those other 5. Okay, those other 3, sorry. So those are the 4 quantitative formulas you will need. You will only need those for the first section of the assessment, so that multiple choice section. So have those ready to go in case you need them. But there are 2 more main equations that you need, and these are the most important ones. And so I'm going to go down below here because you're going to need these for the assignment part, and you may need them for the multiple choice part, but these are the main ones. Okay, so the last concentration formula we learned was this one. The molar concentration is N divided by V. So just listen to this. C, remember, is what we call the molar concentration. It's the molar concentration, and it is in moles per liter. And that's because N is the number of moles and V is the number of liters. Now, I wanted to emphasize that this is all the other ones we went over used milliliters. This one uses liters, and the expectation is that you write the answer in moles per liter. Okay. I'm going to be showing you an example of how to do a question with C equals N over V in a little bit. Okay. The other one that and this is the formula from lesson number 4. The other one is called a dilution formula. And what it is it's C1 V1 is equal to C2 V2. And I call this the dilution formula. And so this is the formula you're going to use if you're trying to figure out how to dilute something. And what we do by definition is these two, remember, it's a concentration and a volume, we would use the concentrated solution you put on one side, and the dilute solution you put on the other side. Okay, and again, I'm going to do a dilution question for you when we do the practice assignment. And so, but these are the two main ones, and you can pretty much be sure that you're going to have to use these two formulas in your assignment. And I'm going to teach you how to recognize when you do each one of these. Okay, so those are two important formulas you're going to need. All right, now look at this. I've put lesson 4, 5, 6, and 8 all on this one slide because I think what you're going to see with this is that these 4 lessons are going to be covered in the assignment, and so you're not going to have to worry so much about these ones in your initial kind of multiple choice. So the rest of lesson 4 was all about preparing solutions, and we went over 2 types. We went over preparing solutions, from a solid, and we said that there were 6 steps involved. 6 steps involved. Your calculations, and then using a volumetric flask, and how you mix things. So I think you should just quickly look at those 6 steps that we covered in lesson 4. And then what we did is we said from a liquid. In other words, if you have a concentrated, let's say, acid, there were 5 steps that you would do. So I would look over those, the 5 steps from the first one and the 6 steps from here. But what I'm going to tell you is that the calculations that you need to do for both of them will be covered in the assignment. Okay. The next lesson was we did reactions. We started to do, now we kind of got into things like precipitation reactions. And again, I'm going to show you in our practice assignment, I'm going to show you a typical question here that you can count on. The only thing I'll say is this was the lesson where we started by doing the molecular equation. We did the molecular equation. Then we did the total ionic equation. And we finished with the net ionic equation. And you are definitely going to have to do one of these on your assignment. So just be prepared, and again, I'm going to take you through that. Okay, lesson 6 and 8 both dealt with stoichiometry. The only difference between lesson 6 and 8 is that, so basically remember that with stoichiometry there are 4 steps. There are 4 steps to stoichiometry. Number 1, write the balanced equation. Number 2, convert to moles and perhaps do a limiting reactant calculation. 3 is do a mole ratio, and 4 is convert back. The only difference between these, in the case of the acid-base reaction, I would expect you to know that an acid plus a base makes a salt plus water. So I'd expect you to be able to write that equation. With the stoichiometry with solutions, this is usually a precipitation reaction, and you have to precipitation reaction where a solid is being formed, and you've got to use the two solutions to predict how much is going to be made. Okay, so this one I am going to do, actually all 3 of these will be tested in your assignment, and in the practice assignment I've got almost an identical question that I'm going to do with you in the next video. Okay, so the last thing from a theory standpoint is our lesson on acid-base theory. And in this lesson, we covered the following things. You need to have these in your study notes. You need to know the properties of acids and bases, and the properties you need to know are taste, conductivity, and these are all right from the lesson, so you can quickly write these out. The feel of an acid versus a base, what happens when you put litmus paper in. When you put litmus paper in, what colors do they turn? This is like a little test to see whether you've got an acid or a base. What happens when you add an active metal to an acid and a base, and what happens when you add carbonate compounds to an acid or a base. So that's all in the notes. So properties. You need to know the 2 definitions we went over. The definitions, one was the Arrhenius definition, and the other one was the Bronsted-Lowry definition. This one basically just deals with an acid gives up an H plus ion, and a base gives up an OH ion. Bronsted and Lowry, we're talking about proton donors. Proton donor was an acid, and a proton acceptor was a base. Okay. Finally, we did a strong versus a weak acid, strong versus weak acids and bases. And really all this involves is how much they dissolve or dissociate. So it's the how much they dissociate or break apart. And remember that strong acids and bases break apart completely, whereas weak acids and bases don't break apart completely. That's really all you need to know. And then the last thing we learned was, well, you can calculate something called the pH of a solution, and you take negative log the concentration of the hydronium ion. Basically, I'm going to show you an example in a second. And then we developed a pH scale. And the pH scale goes from 0 through 7 up to 14, where 0 to 7 are acidic, 7 to 14 are basic, and 7 itself is neutral. Okay. So I just want to do a couple of quick questions here, and then I'm going to take you through the assignment. But look at this, you guys. So this is these are two typical questions that you may expect to see in your, not in the assignment, but in the little quick quiz. So first of all, this first question says, identify the conjugate acid-base pairs. And what this comes from is it comes from the Bronsted-Lowry definition. That's where we covered this. And really, what I can tell you is that an acid-base pair differs by a hydrogen. So watch this. Notice that H2O and OH differ by a hydrogen. H2O has one more hydrogen than this. So that makes them a pair. And then look at this. HCO3 minus and H2CO3 differ by a hydrogen as well. So they are a pair. So first of all, I've certainly done my first step is by identifying which ones are pairs. And now within the pair, one of them is a base and one of them is an acid. And so watch this. I can tell you that this one is a base because it accepted, as it went from this side to the product side, it accepted a hydrogen. Okay, now look at this. That means that this one is an acid because every pair has an acid and a base. Okay, well look at this. Notice on this side, if this was the base, this must be an acid and this must be a base in this pair, because look at this. As it went from this side to this side, it donated a proton to the other one. So here's an example of a question where you'd have to identify acid-base pairs. Please, it's not going to be, all you need to remember is that, first of all, within each pair, they differ by a hydrogen. That's why this one goes with this one. Those two compounds differ by a hydrogen, and sure enough, H2O and OH differ by a hydrogen. And then what I can tell you is that within the pair, there's one acid and one base. The base will accept a hydrogen as it moves over. The acid will donate a hydrogen as it moves over. So that's how I identified those. The one other kind of question you need to know is how to calculate pH. And so look at this. It says blackberries have a concentration of hydronium of this number. So what is their pH? So in other words, to get the pH, I am going to have to type into my calculator the logarithm of 4.324 times 10 to the negative 4. And I got to tell you, all you've got to do is grab your cell phone or your calculator, type in the number. So you'll do second function on my calculator, second function log. Okay, and then I type in that number, 4.324 exp, or times 10 to the negative 4. And my calculator gives the following as the answer. It says negative, and then negative 3.364. But look at this. They want the negative of it. So if a negative times a negative is a positive, so the pH is 3.364. Now, just all you have to remember is that when you type this into your calculator, you're going to get a negative number. In your final answer, you get rid of the negative number. Now, it says, is it an acid or a base? Well, if it was from 0 to 7, it would be an acid, which it is. So therefore, it's acidic. If it was from 7 to 14, it would be basic. If it was exactly 7, you would say it's neutral. Okay, so that's a good example of that question. All right, so those are your study notes for this unit. I know that I haven't filled in all of them for you in terms of definitions and things. I think you need to fill those in. In the next video, I'm going to walk you through the sample assignment or the practice assignment that is very similar to what you would see in the real assignment for this week. All right, you guys, so I'm going to leave you there for now, and I'll do the practice assignment.